Hello, here in this section we're going to be looking at 9.2, graphing quadratic functions. There's going to be one new thing here in this section. It's going to make a really large difference compared to 9.1 when we are graphing quadratics, but all they were doing was starting at the origin, shifting up or down, or opening up or down. Unlike the last section, we're going to have a bx value now, so we're going to start to have a value here in the middle. And that's going to affect what we've already been talking about of the axis of symmetry. You'll see that abbreviated to AOS. Alright, now remember here, and we've been using this already plenty because I wanted to get you guys warmed up for this. To find the axis of symmetry, it's a vertical line. So it'll be an x is equal to situation, and it's negative b divided by 2a. Now, something if you memorize from 9.1, I told you to memorize. You're going to need that. Alright? So, what this is also going to help us find is the axis of symmetry always passes through the vertex of any graph, since the axis of symmetry always runs through it. So really what we're looking at here is whether our quadratic opens down or whether it opens up. This axis of symmetry is that invisible dotted line that travels right through the middle. So since it travels right through the middle, it will tell us the vertex. Now, to find the y-coordinate of the vertex, and this is true for any type of equation, you substitute x. You guys will sometimes say plug in x here. Mathematical term for that would be substitute. Do also remember that the y-intercept is very easy to find, coming from the standard form of y equals ax squared plus bx plus c. Remember here that the y-intercept is always that c value. So 0 because we're a y-intercept, comma, c. Alright. So let's go ahead and jump on in and see how to graph this quadratic, even though it looks significantly more complicated than some of the ones we've seen last week. Alright, so one thing we can determine right away is we can look at this y-intercept of negative 2 and know that our y-intercept is 0, negative 2. Now to find the axis of symmetry in the vertex, we're going to want to start off with our x is equal to negative b divided by 2a. Right, here's our a value is a value is 2, b value of 8. Now notice here that the a is just the 2, the b is just the 8. Do not bring that x squared in x. It's the coefficients only. So we just saw up there that our a was equal to 2, and our b was equal to an 8. So now we're going to go ahead and evaluate here at the formula of x is equal to negative b divided by 2a. We're going to evaluate at our number, so b is 8 and a is 2. So here we'll have x is equal to a negative 8 over 4. So the x-coordinate of our axis, of our vertex, and will also be our axis of symmetry, is negative 2. So that's going to tell us two things. Our axis of symmetry is at negative 2, and the x-coordinate of our vertex is at negative 2. These will always match the x-coordinate of your vertex and the axis of symmetry, because what that axis of symmetry is that invisible dotted line that travels through the vertex. All right, so we're going to be symmetrical around that axis of symmetry. Now to find the y-coordinate of the vertex, we're going to go to the original equation, but everywhere that we have an x, we're going to replace it with the negative 2 that we already solved for. So we have to do exponents first. So we have negative 2 squared, which is 4. 4 then times the 2 is an 8. Forgot my 8 right there. So then here we have 8 times the negative 2 to get the subtract 16, and then subtract 2. And then we just take care of this. So we have 8 minus 16 is negative 8, minus the 2 to get that the y-coordinate of our vertex is a negative 10. Alright, so all the way down here at the bottom, here is our vertex. Alright, now to find other points, it's going to be just like we found other points in 9.1. We can make a table. In the middle of the table, we need to put our vertex, which we calculated to be negative 2, negative 10. We need to put this vertex here in the middle. I don't want the origin in the middle, because as we can see on this graph here, this green line is going to be the line that we are centered upon, not the origin. Right? We won't be centered around the origin on this problem. And then we simply count down. So negative 3 and negative 4. And we count up. And do recall that these two will match. And these two will match as well because we're on either side of the vertex. Now, what you might have recognized is we already know this point. It's going to be the y-intercept. We know this point right here. 0, comma what? Well, it was our c value. 0, comma negative 2. Which means that this value up here also must be a negative 2. So a lot of times on these, you won't have to evaluate every single one of these, partially due to the symmetry around the origin, and sometimes the y-intercept can go ahead and mirror across. So now we're left with either plugging in the negative 1 or the negative 3. I'm going to plug the negative 1 in because it's going to be a little easier than the negative 3. So we're back to the original equation, and now we're substituting in negative 1. Negative 1 squared is 1 times 2 is 2. Then we get to subtract 8 and to subtract 2. When we place all these together, these 2's cancel out, leaving us with a negative 8. So that tells us that this point here is a negative 8, and by symmetry, that point there is also a negative 8. And now we're ready to take this table and get it graphed. So we had negative 1 and negative 3 were both at negative 8. And then we had at 0, negative 2, and negative 4 at negative 2. And we can see we get a nice symmetrical quadratic graph here. All right, and we're going to make a lot of these. We're going to spend a lot of time on this process, getting used to the all the different things, such as the y-intercept, finding the axis of symmetry with negative b over 2a, picking the right numbers to evaluate to make our work more efficient. All right, and we found these other points by making a table with and this was the important part, we wanted the vertex in the middle of the table. If you don't put your vertex in the middle of the table, you will not get these lines of symmetry, which then means you'll have to evaluate a lot more of your points, and you won't, it might not fit on the graph because the numbers get very large. It's all about finding that vertex first, which is what we did with negative b over 2a, and then we went from there. All right, so let's go ahead and graph another one, and let's address just a couple features of this one that we might see right away, because there's some information that we can see right away on this that will help us understand this process more. First thing is finding the y-intercept is very easy. It's always 0, comma, and then whatever your c value is, which in this case is a 5. So we have our y-intercept. And also, you might recognize that this one's going to open down because we have a negative in front of that a value. We learned that in 9.1. All right, now all of these will start by using our x is equal to negative b divided by 2a. We look at the equation to find the a and b values. B is 6. Now a in this case, notice that it is negative. So we have a negative 3. When we evaluate this, we'll get 6 over negative 6, telling us that our axis of symmetry is at 1. So I can fill in my axis of symmetry is at 1. I can also fill in that the x-coordinate of my vertex, because these will always match, is 1 as well. So on our graph, we now know that along this dotted line, that's where we'll be symmetrical. To find out where the vertex goes on that, we will have to plug in that x value back into our equation. So we have y is equal to negative 3x squared plus 6x plus 5, and we're evaluating at 1. All right, well, 1 squared is 1 times negative 3 is negative 3. And then we have a positive 6 plus 5. When we add all these up together, we've got an 11. So negative 11 and then negative 3 to land us at a y-coordinate of 8. All right, so now we know along this dotted line, we're at 1, 8. There is our vertex. All right, now it comes time to find the other points. So this is where we're going to need to bring in the table. And we must put that vertex right in the middle. That's what's going to allow for these lines of symmetry. So counting down would be 0, negative 1. Up would be 2 and 3. Once again, though, and this will happen fairly often, here's our exact same y-intercept that we saw up above. So that's one way to save some time on these, is to recognize that. So if it's at 5, then this number also must be at 5. We could go ahead and graph those. Y-intercept, its reflection across that green dotted line. So now all we have to do is plug in either negative 1 or 3. I'm just going to choose the negative 1 here. So our equation was negative 3 x squared plus 6x plus 5. And we're evaluating here at negative 1. So we have negative 1 squared to get positive 1. Positive 1 times negative 3 is negative 3. Subtract 6 plus 5. So we've got a negative 9 plus a 5 to get our y-coordinate of negative 4. So we have a negative 4 here. And we have a negative 4 here. So at negative 1, we are at negative 4. And then also at 3, if we would have evaluated at 3 in the table, if I would have done the calculations here, we would have gotten the same conclusion of negative 4. And you can see why from the graph. All right, so that's the way that you graph quadratics when you have a b value. That b value changes a lot of things up. It makes us really have to utilize that negative b over 2a formula. Once you do the negative b over 2a, be sure to take that value and do two things with it. It automatically becomes the x-coordinate of your vertex, and then you take it and you plug it back into your equation to find the y-coordinate of your vertex. So let's make a quick note of that. All right, so in step 1, you use negative b over 2a. To find x. Step 2, you substitute x in to find the y of the vertex. And then once you have that vertex, you place the vertex in the center of the table to find the other points. And then you get them graphed. So that's the big 3 there on how to take down these graphs.